Dear audience, welcome to HETV program titled Zeidman Software Forensics and Safe on IP. Today, we are very honored to have the creator for this field, software forensics, Mr. Zeidman, to share the essence of software forensics, which is the science of analyzing software source code or binary code to determine whether intellectual property infringement or theft occur. Mr. Zeidman has developed the algorithms, technology, and procedure for CodeSuite, which has been used in over 100 cases worldwide. Mr. Zeidman has been a consultant and testifying expert on over 250 cases involving billions of dollars of intellectual property rights. Mr. Zeidman is the president and founder of Zeidman Consulting that provide engineering consultancy to law firms regarding intellectual property disputes. And he is also the president and founder of Software Analysis of Forensics Engineering Corporation, SAF, which is the leading provider of software intellectual property analysis tools. He's also the author of the book titled The Software IP Detective Handbook, Measurement, Comparison, and Infringement Detection. Let's welcome Mr. Zeidman.
Hi, Mei-Hsin. Thank you very much for having me. I'm honored to be here.
Mr. Zeidman, thank you for opening Zeidman Software Forensics and Sub on IP on HETV for every Wednesday at 1 p.m. Would you mind giving us the brief introduction of your company's first Software Analysis and Forensics Engineering Corporation and your tool, SAF and CodeSuite? Nevertheless, how to apply this tool into litigations?
I'm Bob Zeidman, and I'd like to thank you for inviting me to talk about my company, Software Analysis and Forensic Engineering, also known as SAFE Corporation. I'm the president and founder of both SAFE Corporation and Zeidman Consulting. I'm the creator of the field of software forensics and the developer of the CodeSuite forensics tool. I'm the author of the book, The Software IP Detective's Handbook, and I have degrees in electrical engineering and physics from Cornell University and Stanford University. I'm going to give an overview of our company, of the technology, of our products, and the markets for our products. Our mission is to be the leading supplier of software forensics tools. We were founded in August 2007. CodeSuite was developed and in use since 2003. And I've funded the company myself, and it's been profitable ever since its founding. Our product is typically used for forensic analysis, including copyright infringement litigation, trade secret theft litigation, and it's been used in over 110 cases worldwide. It's also used for software development analysis, including the implementation and validation of a software cleanroom, and it's used to measure software development time and evolution. Now I'll talk about the technology behind our CodeSuite tool. First, let me explain what is source code. Source code is the human-readable code written by a computer programmer. That code is typically put into another program called a compiler, and the output of the compiler is machine code or object code, which are the binary ones and zeros that are read by a computer and interpreted to be executed as a program. CodeSuite is used for intellectual property protection of software. Before litigation, if you suspect another party of having copied your code, you would use the bidmatch function of CodeSuite to compare your source code to the other party's machine code. Bidmatch would then give signs of possible copying even though you don't have access to their source code. Such possible signs of copying indicate the need for you to negotiate with the other company or litigate against the other company. Once litigation has begun, you will typically get access to the other party's source code. You would then use the code match function of CodeSuite to find matches between the two sets of source code. You would use the source detective function of CodeSuite to search the internet for those matches, determine whether they are common or unique. You would use the code cross function of CodeSuite to find commented out code, which can be an indication of copying. And you can use the CodeDiff function of CodeSuite to find differences and similarities between the two sets of source code. I'm now going to talk about the use and the algorithms behind our CodeSuite product. CodeSuite consists of a number of different functions. The bidmatch function compares source code with machine code to find indications of copying. CodeMatch compares two sets of source code to find indications of copying, even if one of those sets of source code has been modified. Source Detective searches the internet for matched elements of code to determine whether they are common or unique. Code Cross compares functional source code statements with non-functional source code comments. And CodeDiff compares two sets of unmodified source code to find similarities and differences. To find possible object code theft, you would enter your source code into the bidmatch function of CodeSuite, and you would enter the machine code into the bidmatch function of CodeSuite, which would produce a series of correlation scores, and depending on their values, that would indicate whether copying had occurred. To determine whether source code theft had occurred, you would enter your source code into the CodeMatch function of CodeSuite, along with source code from the accused party. CodeMatch would then output a series of correlation scores that, depending on their values, would give an indication of whether copying had occurred. CodeMatch creates correlation scores by dividing source code into its basic elements of identifiers, statements, comments, strings, and instruction sequences. Each of these elements are compared separately in the two sets of code, and each are given separate correlation scores, which are then combined into a single correlation score. I'll now discuss the commercial markets for the CodeSuite tool. The markets for CodeSuite include IP protection, such as when an outsourced software development team wants to determine whether any of its employees use copied or unauthorized code in its product. For incoming software products, when a company has used an outsourced software development team and wants to check that there is no unauthorized or copied code in the product coming in. For mergers and acquisitions, when companies merge or acquire another company, to determine whether the company's code uses any unauthorized or copied software. And of course, for software copyright infringement litigation. For software development, CodeSuite can also be used to implement a software cleanroom effort to ensure that no unauthorized or copied code gets used in the product. And it could also be used to measure software development. The safe approach is to provide tools for complete and fast source code analysis, to provide court-tested results. As I said, the results of CodeSuite have been used in over 110 cases worldwide. And we also train experts and consultants in using the tools so that they can present accurate results. Thank you very much for inviting me to talk about my company and my product. You can see here my contact information. Please connect with me if you have any questions. Thank you.
Thank you very much for your comprehensive explanation for Ceph and CodeSuite. Mr. Zeidman, you mentioned about the cleanroom function in CodeSuite, and you once conduct software cleanroom development project for MediaTek, which is the leading chip design company worldwide based in Taiwan. Our program is in Taiwan, as you are aware. So would you mind further enlighten us what is the cleanroom development and how the clean room project to be performed so that our audience, if they have the needs, they could come to you?
My team and I have actually been involved in a number of clean room development projects. Even before I started consulting and before I started doing software forensics, I worked for a company that had a joint project with another company. And in that joint project, they needed to make sure that they isolated all of the programmers who weren't working on that joint project from the other programmers in the company. They did that to make sure that any code or intellectual property from one company wouldn't accidentally find its way into this joint project that they were creating. And as I got involved in software forensics, my consulting team and I started being asked to supervise clean room development processes. And what I found was, although people had an idea of what it meant to do a clean room process, there was no formal description. There hadn't been a formal description since 1984, I think it was, when someone wrote a book on clean room development and how to protect your intellectual property during some kind of joint development project. But the book was outdated. This was already the late 90s, and the book talked about phone calls. It didn't talk about email. So in my book, the Software IP Detective's Handbook, I dedicated a chapter to creating a clean room, a software clean room. And what it involves is having what's called a dirty room and a clean room. And the places where I see it most often, by the way, are situations where some engineers working on a project for one company leave that company and go to work for a competitor. So that's perfectly legal in most places, in most circumstances, but you want to make sure they don't accidentally bring some intellectual property from the competitor, because that would not be legal. At least it would get them in trouble. So what they do is they put all of the programmers who came from the competitor into what's called a dirty room. And the dirty room is isolated from what's called the clean room. And if a competing program is being developed, it'll be developed by the programmers in the clean room who have had no contact with the programmers in the dirty room, no direct contact, and no direct contact with the competitor from which they came. Then the programmers and the people in the dirty room, and these don't have to be physical rooms, although in some cases that is useful or necessary. But the programmers and the people in the dirty room can write high-level specifications that describe the functionality of the software, but don't describe any specific code. And then all communications between the dirty room and the clean room are monitored by an unbiased party called the monitor that has no stake in whether this new project works or not. They're not a competitor in the industry. They're someone like my consulting team. And so all communications go back and forth are monitored by the monitor to make sure that nobody's passing code or any other proprietary intellectual property between the clean room and the dirty room. And the development will take place in the clean room by programmers who are just looking at high-level descriptions of functionality and are never looking at any original code. So again, in the dirty room, you have people who are contaminated, so to speak, by having worked at the first company and then having left to go to the second company. The clean room are people that are developing code without any contact at either company. And the monitor is an unbiased source, an unbiased party, like my consulting company, that monitors all communications going back and forth to make sure that no proprietary intellectual property is accidentally or purposely sent from the dirty room to the clean room.
Thank you for enlightening us the importance of the clean room. Now, if the audience requires more information, they can reach you or refer the chapter in your book, The Software IP Detectives Handbook, Measurement, Comparison, and Infringement Detection. Thank you again and see you on our next program. Dear audience, please do come back next Wednesday at 1 p.m. for Zeidman Software Forensics and Self-Owned IP on HETV. Do not miss the opportunity to sharpen your skill and enhance your proficiency for career competence.